Assalamualaikum warahmatullahi wabarakatuh, and a very good day. In this part of the material balance introduction, I will cover on the general material balance equation GMBE. Okay, so the balance of materials or mass is based on the conservation of the quantity, okay, inside the particular system. So in our part, the system normally is a reactor or a column or a separation unit. Okay, so the 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 balance of a conservation can be start off with the input or inlets towards the system. Okay, and then plus with how much product is being generated inside the system. Okay, minus with the amount of products going out, outlet, output, minus with the consumptions, means the products is being consumed during the process. Okay, equals to the accumulation. So how much of the product accumulated in a process. Okay. So we have two type of the balances. The first one is the differential balances, and then the second one is the integral balances. Okay, so the differential balances is indicating on the process what is happening in that particular system at that instant time. So normally is in a rate, means the input and output is in over the time. So differential balances is more suitable for the continuous process. While for the integral balances, it is more suitable for the batch process. Okay, because it's happened between two instance of time. Means for the batch example, uh, you have an inlet, process occur, and then after certain times, you have an outlet. Okay, so it is based on the balance quantity of the corresponding amount. Okay. Okay. So for the material balance, we have a simplified rules, okay, rule of thumb, okay, that you can use. So for the total mass, okay, normally we will set that the cogeneration and consumption is equals to 0, okay, because mass is something that cannot be created or destroyed. So it can be consumed, it can be transferred into another product. Okay, converted, sorry, to another product. So if the balanced substance is a non-reactive, so if it's a non-reactive process, okay, so we will set that the generation and consumption is equals to 0. Okay, for the reactive process, it will be a bit different. Okay, and then we assume that the process is in a steady state, then accumulation is equals to 0. So for the steady state, normally is a continuous process. So for continuous process, we assume that our accumulation is equals to 0. Okay. So for the balance of continuous process, okay. So just now the rule of thumb said that accumulation is equals to 0. So we should transfer this one is equals to 0. So if the process is a non-reactive process, so if you are doing a non-reactive material balance, so generation and consumption is equals to 0. So for non-reactive material balance, in equals to out. Whatever in is equivalent to their output. Okay. So for the reactive, there's a method to calculate, and you will cover in the material balance reactive chapter. Okay, so for the batch process, it's a bit complex in terms of identification. Okay, so for example, is ammonia is produced from nitrogen and hydrogen in a batch process. So for at time 0, okay, the initial amount of ammonia, okay, in the reactor, and later at time t, the reactions terminate and the content of the final amount of ammonia are withdrawn. Okay, so there's a time between T naught and T final. Okay. So based on the general material balance equation, so no component enter or leave during the reactor operation. So input is equals to 0 and output is equals to 0. So generation minus consumption equals to accumulation. However, inside the batch reactor, okay, the accumulation is based on the amount of final output minus the final input. So we can see that the general material balance equation for batch process is the initial input plus the generation, how much product is produced, equals to the final output, okay, plus with the consumption. You will try on the exercises for the material balance calculation later on with Dr. Najwa for the non-reactive and me again for the reactive processes. Okay, thank you.